A blockchain, as the name suggests, is a chain of blocks, and each block contains some data. A blockchain is fundamentally a distributed database, which basically means that lots of computers, often referred to as nodes, store a copy of the database and agree to maintain a shared identical state. Once data has been recorded on a blockchain, it is by design near impossible to change. The reason it is so difficult to make a change is because a majority of the nodes running the network would need to agree, and so the theory goes that any responsible participant of the network would not comply. Let's examine a block in more detail. Each block contains some data, a hash of that data, and importantly, the hash of the previous block's data. The data stored is dependent on the type of transaction, but for the purpose of understanding how a blockchain works, it's largely unimportant. We'll just refer to it as the data. The hash is a cryptographic representation of the block's data. A hash is always unique, and importantly, changing the data on which the hash is created would result in a different hash, thus not the same block. The third element of a block is the hash from the previous block. This is what creates the chain of blocks, and is why blockchain is so secure. If we examine the following blockchain, you'll see we have 4 blocks. Each block has its data, the hash of the previous block, and the newly created hash. The newly created hash is derived by combining the data contained in the block and the hash of the previous block. Block 3 contains the hash from block 2, and block 2 contains the hash from block 1. Block 1 does not contain a previous hash, because there is no previous block for it to point to. For this reason, we call this block the Genesis block, the first block of the blockchain. So now we have our chain of blocks, where each block contains a cryptographic representation of the data from the previous block. Now let's look at how this design, combined with this distributed architecture, makes blockchains so secure. Let's try and change the data in block 2. When we change that data, its hash will change. Block 3 now points to an invalid hash, and so we would need to change block 3 and update the previous hash. But in doing so, we would then create a new hash for block 3, so we would have to go and update block 4, and we would have to continue updating each future block in the chain until we reach the latest block. If the blockchain was stored on a single computer, that would be feasible, but this is where the decentralized design of a blockchain comes to the rescue. The change has made our version of the blockchain different from all other copies in the network. Here we have a line of blocks that represent the blockchain until the point in time at which we changed our version. A process known as consensus ensures that our inaccurate version of the data will be rejected. In this lecture, we won't dive into the specifics of consensus, as it can vary between blockchains, and this course section is meant to be an agnostic look at the fundamentals of blockchain. For now, it is enough to say that consensus ensures that only legitimate blocks are added, and that changes cannot be made retrospectively. The chaining of blocks using the cryptographic hash of the previous known block, combined with the distributed application of the consensus protocol, ensures that everyone can be confident that once their data is recorded on the blockchain, it is tamper-resistant and secure. That concludes this short lecture on how a blockchain works at a fundamental level. And don't worry, we will dig much deeper into the specifics of how the XRP ledger works later in this course.